Here we go. So we did a little bit programming here and there in the previous classes. Now we are going to look at some of the hardware. Okay, so we're going to look at some of the hardware. So along with the program, you guys can learn the hardware with it too. And the reason is you guys are going to do labs. You guys see that we have Siemens PLC and we have Allen Bradley PLC, and then with mechatronics there is like 7 or 8 different PLCs connected to the mechatronics. So there's plenty of them. There will be plenty of hands-on, along with the software that is I think that expire in 15 days. So I would recommend you guys to work on it again and again, and hopefully we will find a way to get the software for you for 6 months or something like that. So we discussed this. We have input output module. Every PLC has input output module, and the input module inputs are connected and the output module outputs are connected. Yeah, so, and this is how it looked like. You guys see that in the picture. So that's how it looked like. Make sure this guy is connected good. Yep, it's good. So we're gonna draw this one. Let's make it bigger so it is clear. All right, so as you guys see these terminals right here. Okay, here are some terminals for input, and there is some terminal I think for analog. It is hard to see, but we will talk about analog as we go. For now, all the input field devices get connected here. Right here we got a power supply, we got here a CPU, and then we got input and output. We talked about these already. There is a good picture right here. So here is the power supply, here is the CPU, yeah, and then here are the input output module through which we can connect our different devices that we are going to control. Yeah. Now we have this PLC, okay, and there is a remote PLC. Okay, so this might be sitting, let's say, in a room, and this will be outside in the field. So we can connect the two PLC together. And right here, if you guys see this cable, that is a serial cable. Okay, and these two guys will communicate with each other. Okay, of course each PLC has an IP address. Okay, and most of you guys don't know about IP addresses because you are not IT guys. However, as we go, we have to learn about IP addresses. The reason is when you go out and start working on these PLCs, then you say, man, what is this IP address? An IP address is like a home address. So every PLC has his own address, because if you want to communicate with it, we have to have an address to communicate with it. Okay, so we will talk about this as we go on. For now, you can see that this remote is controlling this hopper, and there is a sensor here, and this sensor is as input connected to an input card. And then depending on this sensor, if this guy is full, for example, I think what is going on here is it is looking at this bin to see if this bin is full. So when this sensor see that this bin is full, what's going to happen? It's going to send a signal to the to close this valve. Okay, this valve. Guys, see? So that is now here you would have maybe a discrete card or analog card depending on the sensor, and then you have an output card, and depending on the condition of the sensor, this could be on or off the valve. Yeah. And the regular I/O, you guys see there is a start and stop button, and the output, the motor is output. So anytime you are building a PLC program, you have to identify your inputs, you have to identify your output, then you write a program. How do you control? All right. We talked about this as we did before. You see right here, I mean input, 2 mean module, or slot or rack, and 0 mean the terminal. We talked about this, okay, in the previous videos. Same thing right here. We talked about it. If you don't know, go to the previous videos. We already have discussed this. There is an analog input output, and analog, you see, one is called discrete, yeah, and one is called what, guys? Continuous. Analog. Discrete mean it is on or off, like the switch in your house. Analog is, you can open a valve. So you got this guy, okay, and this dial. You can open this guy 30%, you can open it 40%, you can open it 50%. So that become analog. You guys following me? Now, you see the discrete is just a subtle, 0, 1. But the analog is continuous, and there is an infinity. Depending on, we can never go to completely precision. Like we can say, hey, I'm at 30.0001, but you can never say for sure that you are, between 30 and 29 there is infinity number. So this is how you say it is a continuous or, analog. Do you see what I mean? And so the discrete input is either 0 and 1, and the analog is, like we have a decimal numbers there. So you can say pressure, you can say temperature, because the temperature could be 27, 27.8. And on the other hand, a switch could be just on and off, 0 and 1. A switch cannot be half on and half off, yeah? So the analog, that's what it means, your pressure, your temperature, your flow. So those would be, if you are getting, now if you are getting 5 and 10, so that is again analog. These are two numbers. But you are talking about a PSI up 50, 60, 70, 80, 90, then we are talking about analog. All right. So for analog, for discrete, we got input cards. For analog, we got for analog, we have analog cards, okay? And you guys will see this in the lab too, all right? And some cards have both input and output connection. So let's look at this guy. So let's say I have this outside a switch, 120 volt, okay? It is connected right here. And all these guys would be connected to neutral too, okay? So we would be connected to neutral too. And this line is 120. So right here, connection 0, and I could have a light, okay? So this is 120. You guys see, and then we will have a neutral wire too. So, and I have drawn this before. If you guys remember, we have drawn this. So this is a card where both input and output cards are in one slot. Okay, they are both packed together. Right here is a I/O module and input output module. You see there are the connections right here. These are the connections where you connect your input and output devices. This is the circuit board right here, okay? And this guy fit into the PLC. So you let me see if there is a picture there. Yep, right there. You guys see? So you just fit it inside, and this card is getting power from the Backplane right here. And if you have another one that is going to be sitting right there, another one is going to be sitting right there. Very nice picture right here. Okay, so these will be your cards, your uh, input cards. There is more example of input cards right here. Okay. So we got discrete, like I said, on and off, yeah? And the examples are, these push button are indicator lights. They are either on or off. We got signaling column. This is an example. Relays. A relay is either on or off. A motor starter is either on or off. We will talk about, for sure, relays, motor starters, and how do we control motors. There are different methods to do that. So the motor controls and those types, they are discussed in the electrical machine class. But we will talk a little bit, and you guys will do lab on motor starter and relays. Okay. So these are discrete inputs. Okay, they are either on or off, and output. Sorry, these are discrete outputs. And here is your discrete inputs, meaning you push it, it is 1. You release it, it is 0. Similarly, selector switch, limit switch, and proximity sensor. And this proximity sensor detects something. So either so like milk, you guys see when they put a milk, and that milk is going in a gallon, and that gallon is just, they make sure, so it is going through a conveyor system, and there would be this sensor, proximity sensor, where they would check to see if this thing is detected or not. Okay, and there are capacitors, sensor, there are, sensors which will generate a magnetic field and see if there is uh, something inside this milk, a metal object, and then they will discard that milk. Okay, so simply mean discrete, meaning on off, whether it is input or output. And then, we can have uh, interfaces. We could have 12 volt. Okay, we could have for the input output modules. Yeah, we can have 48, 120, 230, and 5 volt. So these input output cards which fit into the backplane, they could have any of these voltages. All right. And similarly the output right here, this 5 volt and TTL mean transistor to transistor logic. So usually what is it is either 0 volt or 5 volt DC. Okay, this will make sense as we go down. You have the power supply right here. We talked about this. It's 120. It is going down to maybe 24 volt DC. Okay, there would be a rectifier which what it do, it convert AC into DC. Yeah, and then from here, from this power supply, we provide power to the CPU, and we provide power right here. You guys see that? Here are these pins. They will go in. These pins will go in, and they will get power. Okay. This is a good view. So right here, if you see, this is our input device. So that is a normally push button. Yeah. A normally push button, this is 120 volt. We got a bridge rectifier that will change AC into DC. Yes. We got a Zener diode. This is the first year of you guys engineering class, so we are not talking about Zener diode yet. Then after that, you got the power come here. When the power come here, you guys see opto electrical isolation. So there is, right here and right here, they are not connected wired. Okay, they are connected through light. You can say opto mean light. So what happens is when the electric come here and go around, here is uh, here is 0 or 5 volt. Let's make it that way. So if there is, if this switch is pushed, we will have a 5 volt. Okay, and then that 5 volt is going to, let's say the CPU. Okay, the CPU is going to read, if this is pushed, your CPU is going to read what? It's going to read, let's say 5 volt or 1 volt. And that 1 volt means that this guy has been pushed. Are you guys getting it? I don't know. Let me show you. So I have a space, okay? In this space, in random access memory, okay, I have in this space, what do I have? Let's say I have nothing, yeah? But when I close this, or maybe it is 0 there, yeah? So when I close this, there is 1 there, yeah? So there is 120 volt flowing, but we cannot provide 120 volt to the CPU. It will be destroyed. The CPU only take 5 volt or maybe 3 volt or lower voltages of DC. I hope, are you guys getting it?
Yeah, I think I'm following.
So what I'm saying is this: we got 120 come in, okay, and this is my input, and then 120 is stepped down, okay, to a much lower voltage, and then further it is stepped down, and now we got on this side we got this logic circuit, yeah, where your CPU is, and your CPU cannot take 120. So there, what happens is there would be a light, and that light would hit these transistors, and when it hits the transistor will start conducting. That's the transistor do on and off, okay, either they are on and off. So when it hit the transistor, it will conduct 5 volt, let's say, and the CPU, what the CPU reads, it say, okay, something is pushed, this guy is pushed. If it was not pushed, there would be no there would be nothing, none of this process going on, okay. So this light will turn on, yeah, to processor low voltage DC. So the processor is going to read that in this space there is 1 here. Let's talk about it here to make more sense. This push button is hit. We have 120 volt going here, okay. This is a rectifier. It is converted into what? It is converted into lower voltage. They are not showing a step down transformer, but in the middle there is a step down transformer, okay. So this would be converted into a lower voltage, and then if you see this Zener diode, see when the current is going this way, the job of the Zener diode is to make that the current doesn't go back, okay. Its job is not, so it does not get reflected, you can say, and go back. So the electric come here, then here is a diode, and it makes a light, and that light hit this transistor, and when the transistor get hit, it start conducting, and when it start conducting, what does the CPU say? The CPU write 1, okay. And what is mean by that 1? It means that this input is on. So in my logic, okay, what I do, so if this is on, okay, if this guy is, did somebody say something? Okay, so the CPU say, okay, my friend, you are on. I need to turn on O colon 2 slash 0. And O colon 2 slash 0, honestly, there is 0 in that spot, and he will change it to 1. Sounds good? And this thing will be on, then this light. If you're not getting it, I can draw it for you guys. Are you okay? So let me do it. Okay, let me do it to make sure that you guys are getting it. What's happening is this. It's a simple thing right here. So I got input right here, and this is I colon 1 slash 0. And then I got a light, okay, and this light is O colon 2 slash 0. So when in the random access memory, the computer is, anytime you do on your cell phone, your computer, any kind of digital device which is smart. So when it's your cell phone, so you click on this button. So when you click on this button, what happens? It goes to the RAM, to the random access memory, and then from there CPU look at this code, it executed, and it put it for you on the screen. Maybe it is an app, your camera app or something. Similarly, the CPU in this case look at the RAM, and inside this RAM, if this is closed, RAM means space, it is a space, okay. So what would happen in for this guy, if this is closed, this space will hold 1. So the CPU reads it. Say, uh-oh, 1, okay, you are on. If he is on, the CPU say, okay, what I need to do? We got another space in this RAM, in random access memory. If this is 1, what we will do? Make this 1 too. That's what the logic says. And your light will turn on. Of course, that's what it is. Exactly. That's how it happens in a CPU. Okay, this is how the CPU make decision. I hope you guys are understanding it. So let's go on. This is the output module now of the PLC. So the output where the light is right here, that is your load. Okay. That is your light right here. So we have our input, okay? We have this input, and then it goes. There was some process, yeah, and you guys see up there, right here, this whole process, and this was your input right here. So I'm just representing that by a block, and then we got compute. Then we got the logic, and after logic, then this start. This is the output. Okay. And to put it in extremely simple terms for you guys, it is like this output. This output is like this. So let me put a small transistor, okay, a small switch there, and then I got this light. So if here is 1 for the input, there is 1 in the space, the CPU is going to do what? It's going to close this guy. And when this circuit is closed, what's going to happen? This is neutral. It's going to start conducting electricity because there is 120 here, and this light will turn on. If you guys can see this, then you guys have mastered 1 unit of PLC, which is very, very important. Okay, so they are not wired. What we are doing is, the input and output are not like wired. So I had the light, okay, I had the light, I have this input, and then I have the output. This is just a switch. If this input is on, then we will close this guy, and electric will start flowing, and we have a light that will turn on. And in the middle, what is it doing? It is the logic which is making this possible. In real life, in the relays, this will be connected. This will be connected to each other. Everything would be wired in a relay logic. I hope I'm not losing you guys. Let me pause there.
I'm getting some of it.
So it's a very good question. I turned the recording off. Let me put it right here. I'm going to make a very small one, okay? So here is 120 volt coming in, and here is my switch. So here is the switch, all right, and then here is this neutral, okay, and this neutral go back to AEP, so this would go back, okay. Similarly, on the output, what I have this switch, for make it simplicity and understanding sake, and I have this light, and there is 120 volt coming in. If this switch is closed, there is 120, but this light is not going to be on because the switch is open. Do you guys agree? See, this is
Yeah.
this light is not going to be on. What I am saying is, when I close this switch, the CPU and your logic, your logic is what? Your logic is this. It says check this guy, but who is this guy? It is this guy. He depends on him. So when we close this, the CPU says, let the CPU is checking RAM. When you close this, the CPU is going to check the RAM, and in a RAM, it is what? 1 there because it is closed. So the CPU say, if here is 1, what should I do? Our logic or program says, write So this guy was I colon 1 slash 0, and this guy is O colon, let's say 2 slash 0. Yeah. So O colon 2 slash 0 has a space 2. So the CPU is going to do what? It's going to write 1 here. So when you write 1 here, this light will turn on, this switch will close.